Okay, let's dive into the session. Okay, thank you. And one small request before starting the session. While I'm taking the session, I request everyone to keep themselves uh, unmuted, so there won't be any disturbances while taking the session. Is my screen visible? Okay, going to the basics of drone. So, this is what we will be looking into today. Today's agenda. We will be introduction to aerial robots. Then we will go into quadcopters and their working. Then we will look at how you can make a quadcopter yourself. When we dive into SOP, you might have studied in your detail or might be going to control systems. We will be just looking at the basic concepts of control system related to the quadcopter. Then some high level planning. This is the planning of missions using a quadcopter. You might have heard like we can do certain autonomous or manual missions using drones and finally we will come to the applications of our drones. What all are the applications that is currently available? Okay. Let's begin with the introduction to aerial robots. So, when you hear the word drone, what comes to your mind? Can anyone reply? If I ask some questions, you can reply. Hello? Am I audible? So, can anyone tell me what comes to your mind when you hear the word drone? Is it images like this, or like this? So, this is supposed to be an interactive session. So, I really request everyone to. You can also put it in chat also. Okay. Uh, so, most probably, what you have seen in your day-to-day life is this first one, this image, because you have seen this in maybe wedding during wedding functions, or you might have seen people taking good overhead videos or photos, all kinds of things. And these kinds of drones made by DJI and all are almost visible um, everywhere most of the time now. But I think very few of you have seen these kinds of. So these are everyday, we can say, recreational drones used for photography or just for flying or just for seeing the view from uh, above. But when you come to these kinds of drones, these will be used specifically for carrying a payload or something like that. You can see a payload. So this payload can be as seen here a camera. So these kinds of drone are in professional people. Movie making as in the sense if you are shooting a film or something. So those films will need high quality camera. The weight will also be high. That has such types of cameras on drones like this. We can rarely see this in common. And when we come to a third drone, this is also a drone, but have you? I think you might have seen these are drones for testing or sales purposes or payload carrying or uh, sensation like drone, things, information, stuff like that. And finally, have anyone seen what this is? So have anyone seen yes or no? Chat. What is that? So I'll continue. So these kinds of drones, these are also drones. Most probably we have seen these kinds of things and we normally associate the word drone with things like this. But what you see here is also a drone. Uh, you might have seen this in movie, Hollywood movies, some war movies, mm, go to war on this drone. So these are also called drone. So then a question arises. So what does the word drone exactly mean? All these can be said as drone. Then what does the word drone mean? So the definition of a drone is nothing but a pilotless aircraft, which is controlled by a remote control. Any pilotless aircraft controlled by a remote control can be termed as a drone. So this is controlled by a remote. And this also is controlled by a remote, but the remote will be a huge setup somewhere in some interior. So this is the format definition we can use the pilot plus aircraft. So then we can go to the different classification of aerial robots. As an So we have multi-rotors, which are drones like this, having many rotors. Then we have wing, then we have hybrid. So let's say the difference between multi-rotors and wing. Even in this drone, you can see there are 1, 2, 3, 4, 5, 6, 7, 8. These roads can also be termed as wing. In this is also a wing. Then what is the difference between these and this? In this drone, the wing or term this thing as the here the wing rotates, hence the name rotors. And there are multiple wings, hence you can say multi-rot. But in this case, there is the wing is fixed. It doesn't rotate. This long wing, when you cut through the air at high speeds, it provide you the necessary thrust to fly. So these don't rotate and they are hence classified as wing. Here the wings rotate. So we don't usually use the word wings and then therefore we classify it as multi-role. There are multiple rotating. And this hybrid is a culmination of both multi-rotors and wing. So you have a wing here, you have a rotors here also. So these hybrid vehicles, there are example is a VTOL. This is a VTOL. Means vertical lift off and landing. So For a plane to fly, you need a runway to attain a certain speed, and then only you can take off. So these hybrids are useful when you need to take off from a single position, and but you also need the characteristics of a winged aircraft, which is long flight. You can have very long durations of flight using a winged aircraft. So in such cases, we combine both these and get a hybrid. So these are the three main classifications: multi-rotors, winged aircraft. So I hope you guys got a general idea. You can answer yes or no in chat. Okay, let's move to the next one. So again, coming or diving deep into the multi-rotors, multi-rotor craft, just as I said, a rotor craft with more than two lifting rotors. So if a multi-rotor, what you mean by multi-rotor is a drone with more than two rotors. So in the previous slide, we seen that there are eight rotating wings. So that's why it's called a multi-rotor. So inside the multi-rotor, there are many other categories also. Is my voice clear now? Okay. So inside multi-rotors, there are subcategory which are quadcopters, hexacopters. So first one is quadcopter. So any multi-rotor with four rotors are known as quadcopters, or a drone with four rotors. One, two, three, four. Hexacopters are from the name itself. There will be six rotors. Then there are octocopters which will have eight rotors. Then there is bicopter and tricopter. So normally a question will come. Why do we need so much rotors? So what is the use of quadcopter, hexaocto? Uh, let's talk about it. So basically, for most of our needs, what we need is a quadcopter, which will be able to navigate through the air smoothly, and we can achieve 40 degrees of motion. But the thing is, this is an example of a system that is good enough for our day-to-day. But when you come to hexa or octacopters, the addition you are getting is you can lift more weight using hexa or octacopter. These can be used in a situation where you have to lift a heavy payload, or you need a very stable flight, in the sense that even if one of these rotors are to fail in the middle of the flight, the rest of the seven rotors here or the five here can manage to keep the drone in a stable hovering position, or whatever the position is. So having extra rotors can account to redundancy, or like in terms of failure situations. So for payload and for redundancy, we can use octocopters or hexacopters. Then these systems are known as over-actuated system, because we need only four rotors. So these are six and eight. So it is over-actuated. There's more rotors than needed. And then you come to bicopters and tricopters. These are, you can say, under-actuated system, and these the purpose of these are specific to the application you want to do. So for our case, quadcopter is more than enough. Okay, let's move into the next slide. So we have finished our introduction to aerial robots. I hope everyone was clear about what was multi-rotor, swing, and hybrid, and what different kinds of aerial robots were under multi-role. So now we are going to focus on only one of the multi-rotors, which is the quadcopter, throughout this session. So this is an example of a overhead view of a quadcopter. So in a quadcopter, we have four motors, and usually in most of the drones you see in real life, these four motors are generally placed in a square shape. The layout will be a square. So in quadcopters, the direction of the rotation of motors are also defined. So from this image, you can see that the opposite rotors will always, diagonally opposite rotors will always rotate in the same direction. You can see 1 and 3 are rotating in the clockwise direction, and 2 and 4 are rotating in the anti-clockwise. So this is important because only through this kind of rotation, only we can achieve the leap needed, and then only we can take. So obviously one question comes, can this rotors rotate in the opposite direction? Of course, it can rotate in the opposite direction only if the other diagonally opposite are also rotating in the opposite direction. So if 1 and 3 you want to reverse the direction of rotation, let's say 1 and 3 will become anti-clockwise like this. Then you have to change the direction of 2 and 4 to clockwise. Then you can achieve the same lift and you can fly the drone. So what you have to keep in mind that diagonally opposite rotors will rotate in the same direction, and these two rotation, I mean direction of the rotation of the two diagonal pairs should be different also. These are in same direction and this are in different direction. That is a basic uh, way how the propellers of a quadcopter rotate. So then we come to how what kind of motions a quadcopter can have. So in a quadcopter, we can say there are four independent degrees of motion. Four independent degrees of motion. So these are the first type of motion is accelerate, or when the drone goes up from the rest position or up, or when it comes down from a hovering position, you can call it decelerate. So that is one motion, and that motion is in Z direction. Then the other motions are roll, pitch, and yaw. Uh, roll, pitch, and yaw, which I will explain. So, yaw is, let's start from yaw. Accelerate, I guess you are familiar now when the drone moves linearly in the. So I request the participants to. Okay, so when the drone moves in third axis in a linear motion, so when the drone has a linear motion in the Z axis, we call that motion acceleration or deceleration depending on the uh, which plus Z axis or the negative Z axis is good. So this accelerate is a linear motion. The other three motions, roll, pitch, and yaw, are not linear motions; they are rotational motions. So pitch is, so if you consider this as the front of the drone and this as the back of the drone. So pitch is when you rotate along this y-axis. The drone will, when you pitch, the drone will go forward and drone can go backward also. Apologies for the interruption. Excuse me. Okay, I hope my voice is clear now. As I was saying, when the drone rotates around the y-axis, you can call that motion as a pitch motion. And when the drone rotates around the x-axis, it can be called a roll action motion. Okay, so I will demonstrate this pitch and roll using a real drone. Uh, after few minutes. So before that, we talked about roll, pitch, and yaw, and how are these like throttle is a linear motion, roll, pitch, and yaw are rotational motions. Now let's see how we can achieve this roll, pitch, and yaw, and then I will demonstrate you how a roll, pitch, and yaw will look. So for throttle, let's see this green rotates normal speed and red rotates high speed. So if you want to move up, all these four rotors have to rotate at the same high velocity. So it has to increase the velocity of all four rotors at the same time, with the same velocity. Then the drone can move up. So the session keeps getting interrupted. I genuinely request people to not unmute yourself during the session. Can cause disturbance for other people who are. Please, if you have to say anything, please message in the chat itself. Okay. So as we were saying, if you increase the velocity of all the four motors to the same value, you can move up. And if you decrease, you can move down. That is the throttle control, or how you accelerate or decelerate, or how you achieve the linear motion in the z-axis. Now you come to pitch control. So I said pitch was the rotational motion in the y-axis. So if you want to move forward, what you do is this is the front of the drone. This is the back of the drone. Back to rotors. This is the front to rotor. So if you want to pitch forward or move forward, what you basically do is you increase the velocity of the back two motors and keep the velocity of the front two motors same. So if you do this, you can pitch forward or move forward. And if you do the opposite, if you want to pitch backward or move backward, then you increase the velocity of the front two motors and keep the velocity of the back two motors same, or you can decrease also. So this is how pitch control is. Like, similarly, like pitch roll motion is when you move about the z-axis, like in this picture. So x-axis in this picture. So the rotational motion around this axis will be moving left or moving right. So to achieve that, similar to pitch control, you will to bend left or move left, you will increase the velocity of the right motors, and if you want to move right, you would increase the velocity of the left motor. So it's like similar to when you come towards yaw control. So yaw control is when I said we have a linear motion in Z axis. When you do a rotational motion in Z axis, entire drone will rotate at the same point. So in order to achieve that, we can make the opposite, I mean diagonally opposite rotors rotate with the same velocity, or increase the velocity of the diagonally rotating uh, rotors. So if you want to yaw left, you can do like this. Or if you want to rotate right or yaw right, you can diagonally increase the velocity of the diagonal rotors like this. So this is how in theory you can achieve this. So let's see a small video which will explain.
ஏய் நானும் இது ரிஜிஸ்டர் பண்ணிட்டு இருக்கேன்ல இல்லைன்னா சரி இதுக்கு சொல்லு ஆட்டோமேட்டிக் கார்பேஜ்
Someone is talking in between. I have said from there, please mute yourself. Please don't be a disturbance to other people. So I hope you all saw the video. So that is basically what I explained to you how you can achieve pitch, roll, yaw, or the acceleration motion, set axis, like going upward or down. Okay, now I will show you a real drone and explain how this roll pitch, yaw, and all that happen. Okay, I hope you can all see a drone. I have a small nano drone on my phone. You can see this drone has it's a quadcopter with four propellers right here. So these motions I was talking about. So the motion in its axis, the linear motion is just accelerating up. Will go like this and accelerating down. So this is the front of the drone. You can see this is the back position of the drone. So when I am saying I am doing a pitch, the drone will hit like this and go like this. This is the pitch motion. And when that is when I increase the velocity of these two rotors compared to these two rotors, because these two are rotating at a higher speed, there is a torque like this, and this drone will tilt in the y-axis. This is the y-axis. The drone will tilt like this, and that's how the pitch motion is achieved. And then for roll, this is, I can say, the x-axis. So when, let's say I have to roll to the left. So what I do is I will increase the velocity of this rotor and this motor. And if I increase the velocity of these two, even compared to these two, then it will create a torque in this direction, and the drone will hit like this, and you can achieve roll motion. So this is pitch motion, and this is roll motion. Roll to either left or right and pitch. So now one motion is remaining, which is yaw. So what we talked about for yaw, what have we talked about? So for yaw, is diagonally opposite rotors have to rotate at the same speed. So when you make these rotors rotate at the same speed, the torque will be like this. Or if you rotate these two at a higher speed than the other two, the torque will be like this. So because of the torque, the drone will rotate in the Z axis. It will be a Z axis. The drone will rotate like this, which we call as yaw motion. It can yaw to the left like this, or if you increase the velocity of these two motors, it can yaw to the right like this. So these are the 4 degrees of freedom which we can achieve on a day. And in the beginning, I have said that these are the four independent, these 4 degrees of freedom are independent. So when you, what that statement means, that 4 degrees of freedom are independent, that means that if you are doing a acceleration or going up or going down, or if you are doing a roll or pitch, these movements does not affect the other movements. So if I am doing a pitch, it shouldn't affect the roll or accelerating up for you, and it doesn't affect. So independence means that when I'm doing a roll, pitch or any one of them, it won't affect any other motions that I have described. So doing a roll won't affect the pitch or yaw, or doing a yaw won't affect the roll or pitch. That is what you mean by these 4 independent degrees of freedom. So we have discussed about only one linear motion, which is in the z-axis. And then I talked to you about the rotational motions in x, y, and z. So obviously you will have a doubt about this. Like what what happened to the linear motions in uh, y-axis and x-axis? Why can't we achieve that motion? That is obviously a doubt or a question that will arise in the mind of each and every one of you. I hope you have been listening very carefully. So the reason that is not happening is, the first thing is we only have these four rotors. With these four rotors, we can't achieve degrees of movement more than four. We can't have more than four degrees. And the thing is that when you do a roll motion, so the roll motion is a rotational motion in this y direction or y axis. So when you do a roll motion, The linear motion in y-axis also happens. So you can say the roll motion and the linear motion in the y-axis are in a way coupled to each other. So I will explain why that is happening. So for acceleration, as we were saying, when you increase the
இது பண்ண
velocity,
மாட்டேன் இது பண்ணுமா பண்ணு.
I again request participants to keep themselves muted. Okay, as I was saying, when you are accelerating up, all the four motors are rotating at the same speed and giving you a thrust or force in the upward direction. So we have a force in the upward direction. You move like this. Even if you are not accelerating, the four rotors are rotating. You will always have a force in the upward direction, which is perpendicular to the plane of your uh, plane of the drone. So the drone plane is like this. The force will be perpendicular to the plane of the drone. So while you do a roll motion, so roll was, if I want to roll right, these two motors will have a higher velocity and the drone will tilt like this, like this. Okay, sorry, when you see this will be left and this will be right. Okay. So this is what you are seeing, I guess this is left movement. So if you want to move left or roll left, you increase the velocity of these two motors and the drone will tilt like this. So even when the drone tilt like this, you, I said there is a force generated due to the motion of all these four rotors. That force will also get tilted. So due to this tilting of that force, the drone will start to move like this. So when you are not doing any roll, pitch or yaw, the force is pointing upward and your motion will be like this in the z axis. But when you roll or let's say you pitch forward, when you pitch, the force direction of the force will be like this, tilted direction, and this will allow the drone to move in this direction. That's how when you pitch this forward motion is achieved, and when you roll the drone, this left or right motion is achieved. That's how this motion gets achieved because we increasing the speed of these back rotors will give you the tilt angle and then the force start acting in this direction and which makes the drone move forward. So that's how a drone will move forward, backward, left or right. And as I was saying, this motion, that is the pitch motion and the movement in the uh, x-axis or the front and back movement are coupled to each other. So these are not independent movement. The rotational movement, which is the pitching and the linear motion also around the x-axis happen simultaneously. So they are coupled. So that is not a independent degree or degree of freedom as you are defined. That's why a quadcopter will only have 4 degrees of 4 independent degrees of freedom. And the basically you can say if you want to have uh, linear motion in X, Y, or Z, the drone then like drone should be able to hover like this in there. So when I do a pitch, the drone won't stay in its place like this. Is my video visible? Okay, the drone when you pitch or when you roll, the drone won't stay in the place like this, but move forward or move to left. That is because of this, it doesn't have that independent degree of freedom in that X or Y axis. You can only move in X and Y axis through rotational motions, through roll and pitch. So I hope you understood what I was trying to say about the motion of the drone and how there are only four independent degrees of freedom, and the linear motions in x and y directions are coupled with the rotational motions in x and y. Only in z direction we have a uh, independent linear motion and rotational motion. So that's it with the thing. So please respond if you guys have understood what I was trying to tell you. Please raise your hand so you can type yes in the chat. Because this is an important aspect of how a quadcopter works. You have to understand it to go further. Anyone, please respond. Hello. Can anyone respond yes or no in the chat that you have understood what I was trying to tell you? Or if you have any doubts or anything like that. Okay. So I hope everyone has understood the basic. It's really simple if you think about it for some time. So yeah, yeah. Okay. Let's move to the next question. So that was all about the basic of quadcopters and their workings. So now we come to the part where I tell you how you can make a quadcopter or what are the components that is needed to quadcopter. So can you guys list the parts you think will be there to make a quadcopter? The chat. Whatever you think is needed to make a quadcopter, you can mention in the chat. You can type like whatever you think is part that you can use to build a drone. You can type it in the chat. Motors, blades. By blades, I hope you mean propeller. Okay, motors. Okay, other than that, what else you? Only motor and propeller enough to make a drone. What else do you see on a drone? Only preparing drone. So, what do you mean by this controller? What that the handheld controller or some controller which is present on the drone itself? Okay, okay. Let's dive into the session. Which for those who need of converter. So this is a listing of the components you need to make a quadcopter on your own. So first of all, you will need a frame, then propellers, then you need motors, then you need motor drivers for that. Then you need something known as a flight controller. This term might be newer to many people. Some of you guys might know what a flight controller actually is. And I will tell you in detail what it actually means. Then you have a remote controller, RC controller. So in everybody's childhood, we would have had a RC control car, like which we control using a small video. Similarly, for controlling a drone also, we need a remote control. Then you need a receiver also on the drone side to receive these signals. Then you need something known as a DNSS receiver. Can anybody tell what this means? DNSS receiver. for replies in the chat.
Sir, global navigation satellite system.
Okay, global navigation. So this is basically GPS. This is the proper term, PNSS. And GPS, as we commonly know it, GPS is a term used in America and all. So this is the correct term for that. Then we have a battery, and then we have the software or the firmware, which will tell the hardware how to and what to do. So let's go through each and every one of these. First, let's go through the frame. So these are some of the commonly available frames that you can see on the market for a quadcopter. So this is a plastic frame. This is a frame which is a combination of plastic as well as carbon fiber. And this frame you see here is entirely fully made up of carbon. So this frame will act as the body of the quadcopter. And the choice of the frames also depend on where you are flying on. Uh, if you want to lift payloads or not. So plastic frames are good for recreational flying only if you want to fly. But the thing is, crash the drone is there is a high possibility that this frame will. So if you are new, like if you want to lift payload or you are sure you will crash or there's a possibility of crashing, I recommend you can choose carbon fiber. When if it crashes, it won't break easily, and this strength of the carbon fiber will allow how higher payload.
Hello.
Yes, was somebody saying it? Let's move on. That's all about frames. Then you come to propellers. So in case of propellers, there are many different propellers. Uh, uh, Propellers with two blades, tri-blade propellers, propellers with four blades. Then there are different materials. Some propellers might be plastic. Some propellers might be plastic, carbon fiber, combination of plastic and carbon fiber. Then there are also wood propellers. So this choice of which kind of propeller to use will depend on what kind of motor you will use. And the amount of blades on a propeller also determines the use case. Like if you have seen drone racing and stuff, you most probably have seen the motors attached to a tri-blade propeller. So tri-blade propellers can be used in scenarios where you need the very fast and agile movements. And these two-blade propellers can be used in cases where you need a very stable flight or even carry payload. Or four-blade propellers also provide very stable flight and payload more blade propellers and tri-blade in case of speedy drone racing also. And the choice of material also will depend on your particular use case. So we have come across train propellers, and the next one is motors. So in motors, we have brushed motors. So these kinds of motors are, you can see these in drones, but those kinds of drones will be cheap and the life of these motors are also very less. So after using it for a good number of times, the motor will be clear itself out and not be useful after a long period of time. And then you have the brushless DC motor. These are the models commonly see or use in the drones. And you know the difference. I hope you guys know the difference between brushless DC motor and a brushless DC motor. I'm not going to go there. I hope you all know that. So what we commonly use are brushless motors. These motors will have a longer lifespan and on around cc, and hence they are very suitable for our jobs. So then you have to have motor drivers. You can directly connect this motor to the controller. So you have to have motor drive. But in the case of you are making a ground robot or something, we'll use a motor driver to connect or give the motor the sufficient power it needs directly from the battery. So for the brush motors, we have a brush DC motor driver. These kinds of things you are also using ground robots. And for brushless DC motors, we have something known as electronic speed controllers or ESC. So in an ESC, you can see these red and black wires. These two wires will be connected to a battery. These three wires will be connected to a motor. It will be a three-phase signal. And this is the control signal which will uh, connected to the AC. And this control signal is originating from the controller, which controls the movement of the rod. So these control signals will be can be PWM signals, or if you you know more about drones, or if you dive deeper into drones later on, signals can be short signals. That is a common type of signal used for controlling the ESC of the drones. So we commonly use these brushless motors and electronic speed control. Then we arrive at the term which is known as a flight controller. So uh, you might be newer to that. So basically, flight controller, what flight controller means is a computer capable of running very complex algorithms or whatnot to control the drone or the aircraft. So this can be termed as the brain of the aircraft. This controls what the drone should do when you give some signal, how it should move, or it will collect data from the sensors which are on the drone, and this will then in turn give the ESCs the required PWM signals or B short signals. So these, in a simpler terms, is known as the brain of the quadcopter of the drone. Just like we have a like you say CPU is the brain of the computer or something. So these are termed as the brain of the drones. So there are different types of flight controllers available from different companies. There is Pixop, there is Fluke. Then these are actually big controllers and actually used in not in the drone like some small drones. This controller is the one used in. I showed you a drone previously in that smaller drone. These type of controllers are used in that smaller drone and they cost less. And these are the old ready-made flight controllers. But if you want to design your own flight controller, you can use Arduino Uno, even Arduino Uno to make your own flight controller. So the choice is yours, the which flight controller to use or you want to make a flight controller on. Then the next thing is you want to control the drone. So there is a flight controller and there is motors, there is ESC, there is main propellers. But someone has to send these signals for the drone to know what to do, fly in what direction. And so for that, we use a remote controller or a RC controller. So these are the remote controllers we use to fly the drones. Many of you might have seen. This is a controller or the transmitter that we hold in our hand, and this is a receiver that we attach to the drone. So this will receive signals transmitted by this controller, and these signals will in turn be given to the flight controller. So these are what we used to fly drones we make on our own, or yes, the drones assembled by us. These kinds of controller you might be familiar with this when you buy a drone from the market ready-made, like buy a DJI drone or something. The remote controller might look something like this. And this is something of a controller made in the software itself. So this is an app. So this app you can control the drone. The functionality of these controllers, but you can control the drone by itself. Now we come to what someone just said, GNSS, Global Navigation Satellite System. So these kinds of these are sensors or extra components on a drone. These things we actually need when you want to know the exact position of the drone, where the drone is located in the world, or what is the position of the drone. Or if you want to do maybe say rescue missions or something, you want to move from one coordinates to another coordinate. All for all that you need a I mean global navigation satellite system or GPS, or maybe for doing what stable flight in outdoors. You want the drone to go to a particular position and uh, keep itself hovering at that position. You need a GPS in order to achieve that kind of control at very stable control. So these are some of the GPS receiver. This is one of the common receivers you can see. These are for smaller drones. These kinds of receiver we use on nano drones. The drone I just showed you. These are normal GPS modules. Then you come across something known as something like this, which is known as RTK GPS. So what is special about this compared to the other two is can provide you very, I mean, much more accuracy up to centimeter level. We use these kinds of article images. You can, after this session, you can Google these things and check what is the difference between a normal images and an article image. So this is needed if you need very high accuracy, positional accuracy. So that's all about the GNSS system.
Stick here, I hear. Unmute.
So please unmute yourself,
Ishan Ansari.
Ishan Ansari.
It's in there.
Please mute yourself, Ishan. Then we come to the powerhouse of the drone, which is a battery. So you can see three kinds of batteries. This is a LiPo battery, which is a lithium polymer battery, and this is the most common batteries used in drones. These are uh, lithium ion batteries and lithium metal hydride batteries. So what we use mostly in quadcopters or drones or hexacopters, octacopters, whatever, or even in fixed wing aircraft, all these are LiPo batteries because the rate of discharge of these batteries high, and we need high discharge rate in terms of for use case in drones. So the most commonly used battery will be LiPo battery, lithium polymer. And if you are about like choosing a battery or choosing what should be the capacity of that battery, all will depend upon what is your use case and what kind of drone you're flying. And finally, we come to the software or firmware of the drone. So these are some of the, um, popular flight controllers, firmware or software. There is PX4, Betaflight, Autopilot, and AINA. So PX4 and Autopilot are usually used for the small drones. Betaflight and AINA are used for very smaller drones and that racing drones. We use
Hi,
this for
man.
FPV drones, India Fighter 9. I again request Ishan to please stop your video also. I want you are creating a nuisance for others. Please. Okay. Let's continue. So this was what I told you about software for the controller. These are used for small to big drones and this Betaflight and INAV are used. Betaflight is used for FPV drones and INAV is used for fixed wing aircraft, like winged aircraft on all, mostly INAV is. So I will show you some website. This is the website of that PX for autopilot or so somewhere for the down PX for autopilot. So if you are interested in So if you are interested in making a drone on your own, or if you want to know how to choose the exact kind of motor will, which motor to choose for which frame, and what kind of propellers will go on to that motors, what kind of battery should I choose, which flight controller should I choose. All that data you can get in this documentation. So whoever are interested can go through this documentation. There is tons of concepts ranging from basic concept, what is a drone, different types of drones and all, then what are all the hardware, sensors and all that is used. You can get all that from here. So one website is this PX4 and other is website of another autopilot which is Autopilot. So for Quadcopters, we go to Copter and whatever the documentation is given clearance for setting up your own drone. If you face any issues while setting up, so everything you need to know about drones are basically in these two websites. So I will put link in the chat. So those who are interested can go to these links and learn more about drones more detail. So that was all about how to make your own quadcopters. So now we turn over to the next part, which is the control system or what is actually happening, how with the drones or how can we control a drone actually. So let's move into that. Before that, is everyone have everyone understood the previous session, like previous one, how to make your own quadcopter? Everyone understood what to do and where to look and all. Then reply yes or no in the chat. Okay. Since people have understood, let's move on to the control system part. So, initial questions. Do quadcopters stabilize by their own? Yes or no? How do this is how do quadcopters stabilize by their own? But do you think quadcopters can stabilize by their own? Say you can answer yes or no. No. So you are saying quadcopters can't stabilize by their own. Somebody is saying yes. Okay. So there are two answers. Quadcopters can stabilize by their own. Yes and no, it can't stabilize by that. So it depends on how you are controlling the quadcopter. So if you are saying the quadcopter is in an autonomous mode, then it can stabilize by itself. No external or user input is needed. It will stabilize on its own. That's a higher level control, and you need to learn more about quadcopters in order to achieve. That is when quadcopters will stabilize on their own. So the placement quadcopters will not stabilize on their own is when it is not in autonomous control and the user has to control the quadcopter to stabilize. So both those answers are correct. Depends on what context here. So how do quadcopters stabilize? How is it stabilizing? How can a user control the quadcopter? So earlier, while we are going through the components or what all you needed to build a quadcopter on your own, I mentioned we came across something known as remote controller and the receiver. So it is through that remote controller, user like us is able to send the control signals. So to move forward or move backward, that control information is sent from the transmitter, and uh, on the drone there is a receiver, and that receiver accept these signals from the transmitter and then pass it on to the flight controller. That's how the drone. That's how the drone will know where to move, how to move, and stabilize according to the user's input. Okay, so first of all, let's start with the motors. The end point of whether the quadcopter needs to accelerate up or down or do a roll, pitch, or yaw motion. Everything is determined by the velocity of the motors. That's why we are going to start with the motors. So all these are start with the motors. So basically, whatever velocity the motors rotate with, which motors rotate with what velocity will determine what kind of motion a quadcopter will have. So basically, we have motors. So for giving data to motors, we need motor drivers. So motor drivers, as I said, we can give PWM signals and all. So we can give RPM or velocity at which the motors should rotate in order to do a forward, backward motion or left or right motion, whatever. So do you think the user can directly give the uh, velocity at which the motor should rotate directly to the driver? Can you do that? Yes or no? What do you think? Can the user give RPMs directly? No. User can't actually directly specify the RPM or the velocity at which the motor should rotate. So in that case, we'll have some kind of a smart controller in between, which will give the RPM or the velocity at which the motor should rotate to the motor driver. And all the user has to give input that to that smart controller. So here the user will give angles as the input. So, so the user can say to the controller that I want the drone to move or pitch forward in 10 degrees, pitch forward 10 degrees, or roll left by 30 degrees or something. So the user can say that to the controller. Then the controller is smart. It will know what kind of motor velocity or RPM is needed to achieve that kind of. So the controller can the controller do that just only with the input from the user. Only with this input can the controller find out what kind of RPM or velocity is needed for the drone to achieve that input. What do you think? Yes or no? So can the controller only with this angle input calculate this motor velocity needed for achieving these motions? No, we can't, because there needs to be some kind of feedback from the motors or from the system itself, the quadcopter system. Otherwise, you are giving input to the controller and you are providing some output, but you are never knowing whether it have reached that particular needed angle or not. So this is the basic control system concept where we get our feedback from the system. So I can classify this driver and motor together as a quadcopter. So this driver and motor, this will together form the quadcopter system in this case. And from that quadcopter system, through sensors, we will have a feedback that we will give to the controller, to the smart controller, along with the angle. So for the controller, now there is the angle input given by the user as well as the feedback from the sensors. So now, is it possible for the controller to generate the motor velocities accurately? Uh, what do you think? Yes or no? I will continue. I am not seeing any difference. Okay. So when you have a feedback from the quadcopter system itself through sensors, these sensors can be accelerometer, gyroscope, or some other sensors. Accelerometer and gyroscope together you can term it as an IMU. So this IMU, earlier you might have a doubt. I haven't specified accelerometer, gyroscope, or the combination of those two IMU anywhere in the session where to make a quadcopter on. So this accelerometer, gyroscope, magnetometer, etc., or barometer for measuring the altitude, all these are present in the flight controller hardware itself. All those are inbuilt on that. So that flight controller hardware, when you say consists of all these accelerometer, gyroscope, magnetometer, barometer, etc. So through that IMU or through accelerometer and gyroscope, it will get the position and orientation of the quadcopter system. And through this feedback system, this controller is able to accurately calculate the desired velocity for to achieve the desired motion. So it will be like user will give, I want to go 10 degrees. So initially I want to pitch 10 degrees. Initially the entire system is at 0 degrees without any roll, pitch or yaw. And the user gives this and we will have a sensor feedback. So the um, pitch we want to achieve is 10 degree, our current value is 0. Then 0 minus 10, we will calculate that error and this controller will provide the necessary motor velocity until that error becomes 0. So until this entire system comes to a 10-degree peak, this controller will give the velocity. After that, uh, error is 0, your required motion is achieved. Now again comes the question, is the user able to directly give angle inputs to the controller? Can the user specify, like I want the, how can a user specify, like I want to give 10, I want to move 10 degrees, I want to move 5 degrees to the left. Is it possible for the user to specify like that? What do you explain? Is it possible for the user to say, I want to do 10 degrees, 30 degrees, something like that? No. It's It is actually no, you can do it actually, but it will require very high level of control if the user wants to specify. So one of the example is if you are doing FPV racing, you actually from the controller you will give, and it's like a angle values. You are giving angle values from the control level. So it is possible, but you require very high level of control for the user to directly give angles. So what we normally do is we will introduce one more controller in between this controller and the user, which is a controller controlling the position. This was a controller controlling the orientation. Here now the user can give position as an input to the smart controller. This controller will generate the angles needed for that particular position. Then it will give to this controller, which will again in turn generate RPM to be given to the motor. So here this position will be in terms of X, Y, Z coordinates. So let's say I want to move in Z coordinate some 2 meters, which will be like a motion in Z axis that is to make the drone move up by 2 meters. So user is specifying that position, and this controller will give that angle. So similarly like here, this controller also needs a feedback whether to know whether that particular height has been achieved or not in the example. Even here also, if you want to do like move, make the drone move left by some uh, 50 centimeter or something like that, you can give that information to this controller, and it will make the drone move that 50 centimeter. And just I have said earlier, uh, using that error approach, if the error between the desired position and the current position becomes zero, so we will monitor through this sensor the particular motion is achieved. So this is in a way a control system called control quadcopter system. If you say new position in X, Y, or Z direction, there's a position controller which will give angles. What angle should be need for achieving the particular position. The angle is into another controller, orientation controller, which will generate RPM, which is given to motor drivers and then to motors, which will make the quadcopter achieve that motion. And through sensors, we are taking the feedback so that the controller will know what RPM to be to achieve that particular motion. So this is a brief overview of control system. I hope everybody understood at least what was happening behind what is happening actually inside them. Could you please say yes or no? Okay. So that was the basics of control system that is happening in that quadcopter. Now we move on to some of the remaining topics, high level planning. These are all household topics. Go through. So high level planning is it's kind of a mission planning, you can say. So this is a screenshot of there is a software known as Mission Planner, which is used to plan missions for the group. So in this case, what you see is the map of a place overview or the map. And these points we can place these points on the map. And you need to have GPS on your drone or quadcopter to achieve this kind of mission mode or high level plan. So you just specify the starting position or the home position. You use the software, click on this then you specify it as home. So this is where the quadcopter will start. When you specify other positions, key points will be known as waypoints. 1, 2, 3, 4, 5. Then again back to back. So what happens here is the drone will start from here. These all so once you use this mission planner software, this comes under ground control station. So all these you don't need to manually make the drone fly. This is a kind of autonomous model. So you just plan or you just tell the drone where to go in the map in terms of GPS coordinates. So the drone will start from here. You'll autonomously go to first waypoint, then second waypoint, third, fourth, fifth, and then come back and land on the home. So these kinds of mission modes are used for maybe if you want to map out an area, or if you want in agriculture, you want to go from sport. So if this is a field, you want to go through the field and take some photos of the crops or distribute pesticides or something. You can use this kind of mission mode. So these mission modes and all, if you can search in Google like mission planner. So again, in that Autopilot documentation only, you would see mission planner. This is the software that we use to plan all this. And you can refer that Autopilot documentation itself to get more in-depth information about this application and how to use it to plan. So I'm not going into it, but those who are interested can go in this and learn more about it. So after the mission mode, there is autonomous mode. Which, in autonomous mode, we do path planning algorithm. So there are known environments for path planning and unknown environments. So autonomous means there won't be any user control. The drone is supposed to do everything by itself. So for a known environment, as you know, you can use A star, B star, or RRT. This is a random rapid the exploration algorithm. And unknown environments, you can do bugs algorithm, FH or ADP. These are the names of some algorithms you can use in a known environment. The, the quadcopter or the drone already know what is in the environment. And then you can use these algorithms to calculate the path from point A to B. This is where the environment is unknown. This is you can use it in search and rescue missions. When the environment is unknown to you, but you still want to navigate through that, you can use these algorithms and all. And the unknown environment mapping and all, would have heard about, I don't know, maybe you would have heard about SLAM, simultaneous localization and mapping language, where you attach a camera also on, to the drone and do mapping of the area. So if it is an unknown area, also you can do mapping and you can navigate to water. So these all what I'm talking about are very high level stuff and not included in this basic. Those who are interested can go through this. Then we finally come to the last portion, which is the applications. So one of the applications of the quadcopters or the multirotors or the drones in general is delivery of packages. So you can see what we have learned here is if you want to have lift a payload or something, you should have a extra or a octocopter if you want to have high payload capacity. So here you can see a drone delivering a package. So just like you can see in the outer countries, in the US, you can do Amazon uses drones to deliver packages from their warehouse to people's houses. So one application is delivery. Then the other is agriculture, as I mentioned earlier. Drones can be used for spraying pesticides in the field if you do a proper mission planning. go from here to here, here to here, and all. Then uh, apply pesticides on your field using drones remotely. Please unmute yourself. Please mute yourself. And the other application is mapping and photogrammetry. You can map an entire area and create a map of the environment using the drone. So these kinds of drone will have a high resolution cameras and lidars. I mean, on them, which will help in this mapping for photography. Then drones are also used for surveillances by police or military and all. Then for transport, this is kind of a future concept that you can use a drone to fly from one. Then this is the most common use case everyone would be familiar with. This aerial cinematography and photography. This is a great drone idea. So most of us, you have experience with drone, might have used some kind of delay drone to do photography or aerial video. So this is a video of and see capabilities of a drone in aerial photography. Uh, So that was a video on aerial photography and on it's very beautiful to look at. You can go and search on YouTube all these kinds of videos. Then the last application is racing. So here you can see one guy is flying. These guys are flying on this is for the safety need. First person view, safety mode of flight. You can. So this is where you don't
Hel-
show race. See, come see, you see bike races and stuff. You can use drones also conduct races like this. So this is the food that the pilot is seeing to his goggles on his chest. The pilot sees out in video also the drone like this and is able to control the drone very swiftly and quickly. Yeah. So that was it. If you guys have any questions regarding this, you have to answer. Now you can unmute yourself and ask whatever you want to know regarding this session. Anybody having any questions? So nobody has any questions or queries or wants to know anything regarding quadcopters or drones discussed in session can raise your hands or mute yourself and ask or
Running the 100 studio.
can ask in the chat also. Wait for 5 minutes. If you don't have any questions, then we can end the session. So those who are interested, be sure to visit these two links for the websites I gave you. You will get a more proper understanding of how you can build the red drawn and
Hello, sir.
yes.
So, do we get certificates regarding the session?
Yeah, just a minute. Uh, we haven't currently planned on giving any certificates, and if there is plans to give certificates, we'll mail the certificates to your email IDs. Any other queries?
So,
You are not clear. Hello?
sir, what is meant by the quadcopter dynamics?
Quadcopter dynamics is what kinds of motion a quadcopter can do, and how you can achieve all these motions and all that. That we have discussed about in this session.
So, thank.
Any other doubts? Okay, if no one else is having any doubts, you can all leave this session and we'll end the session. Hmm?